hope to be done by 11:30 today. I know that there's at least 2 people in the room who are working on an internship, excuse me, and they have somebody coming in. Is that today or is that next week? That's right, it's next week. We'll still be done by a little bit, at least a little bit early today. We should be at least. All right. We're going into Chapter 6 today. So if you've got your book handy, again, I really wish I had a PDF for this, but I don't. And the book starts on page 357. If you were in the previous class, you're going to hear a lot of things that were very similar from C#. All right, there'll be some new stuff and some different stuff. There's also some stuff in this chapter I'm going to spend very little time on. For instance, they talk about how to override the toString method. I've had you doing that for several chapters. They talk about the this parameter. I've shown you what that means in several chapters. So some of this stuff we're going to kind of go through rather quickly. That's why I said I think we should be done fairly early. Remember, next week will be lab the entire week. All right, and as I mentioned, but if you weren't here in the last class, you didn't hear this. As of right now, I'm probably going, we get 2 off days a year, 2 pay days off. I'm probably going to take 2 weeks from today because I've got a family obligation. All right, I'll let you know next week for sure, but that would be April 1st. No April Fool's joke or anything. I really would not be here. If that's the case, this is your room. This is not my room. I hate it when people say you want to go to Jeff's lab. It's not my lab. It's your lab. But the room is open for you, and John will still be here, or whoever is the lab assistant will still be here. All right? And I'm keeping these up just so we've got something to show on the screen. I've got the PowerPoints. And it does give me a chance to go over the stuff that the author talks about in here. So we went over the other day. Now I'm just drawing a blank. What was the program that we did? Months. Right. Thank you. We did the months program, and you're going to be doing another one that's called geometry. I don't know you don't have to know geometry. All right. Every formula that you need, and there's just a couple of them, they're shown in the book. Okay. I will show you what I'm expecting by the end of class today for that. All right. So, as you can see here, here's our topics here and here. I'm not going to read them to you. When you think the word static, all right, think of 1. Static means that it's shared. Maybe you've even heard me give this example before. But let's suppose that we were going to write a Java program, and what we were going to do is we were going to create a class that was called person. Okay? And based off of that, I was going to make person objects. So I'd make a Luke object, etc. You get the idea? Well, if every time I did that, I wanted to add to a counter how many person objects I had. If there's 10 of you in here, I'd want that counter to be 10. Make sense? 1 counter with a value of 10. If I don't make that variable static, what happens is I get 10 counters and each of them have a value of 1. It's not what I want. So static, again, implies 1. There's a few other things, but we'll talk about those also. All right? All right. One thing you got to realize, they talk here about overload methods. I hate when he says stuff like this. Overloaded methods and overloaded constructors. A constructor is a method. It is. Do you remember the other day when we did the months program that we overloaded the constructor? We had one that was a no-R constructor, so nothing was in the parens. Another one where we passed an integer for the month number, and another one where we passed the string for the month name. Remember that? That was an overloaded constructor. Anytime you take a method and you've got the same method name more than once in a program, that is an overloaded method. All right? But when you overload the method, what goes in the parens has to be different between them because their names are identical. All right? Passing objects to arguments as arguments to methods. If you were here in the last class, we talked about pass by value and pass by reference. And I mentioned at that time that in Java, your 8 primitive data types, let's see if I can remember them all now. Int, byte, short, long, boolean, char, float, and double. That's 8. Those 8, when you pass a variable of those types into a routine, They're always automatically passed by value. You can't change that. There's no ampersand or ref or out like you can use that we talked about. You can't do it. All right. Well, don't worry about it. We'll talk about how you get around that. Java actually uses something that C uses. They're called pointers. But the thing is, Java doesn't let you manipulate the pointers. Everything that it does with pointers, it does behind the scenes. Because evidently the people who created the language thought, nah, you'll screw it up. And to be honest with you, in C, it's so easy to screw it up. It is. You know, I've mentioned this before. Maybe you've heard me say this in other classes, but remember the old blue screen of death? All right? Some people are, just in honor of that, Eric's wearing a blue screen of death shirt today. All right? But with that blue screen of death, more often than not when that came out, it was because the program was written in C or in C++, and you were using a pointer and you were overriding memory. That's almost always what it was. All right. Not only can you pass an entire object, so like a month object like we did. And guess what? We did that. Remember that we actually, when we had that greater than thing and that less than and that equals, we were passing an entire month object. I think Micah asked that. What was that? What's that M2? It was a month object. All right. So when you pass an object to a method, you pass it by reference, meaning any changes you make to the object inside of the method are permanent changes. All right? And you can return an entire object. Remember I said last hour, you can only return one thing from a method, but that one thing can be an object that can contain hundreds of things. That's okay. All right? The toString, again, we've already talked about. I'm surprised. Nobody asked me this the other day, and maybe that's just me, but sometimes when stuff like this happens, I get surprised. If I do this, one thing I cannot do in Java, this is illegal. In fact, I think you won't get an error message, but that's not going to do what you said. If you took a guess, if I took a guess, if I was sitting there where you are, somebody said, is that going to return true or false? I'd say true. Guess what that returns? False. When you use double equal in Java, not C#, you can do this in C#. In Java, what this says is, do both name1 and name2 point to the same area in memory? Do they? No. They're two different areas in memory. So this, we'll call it a Java no-no. All right? The way you do that in Java is you say if name1 dot equals name2. That's how you do it. Well, that's an ugly syntax. Well, I don't care. That's the way that you do it in the language. And I showed you that in the months program, and not a person asked me. Once in a while, I'll ask you questions, but sometimes I won't, just to see if somebody asks me. And no one did. But that's how you do it in Java, when you want to check for equality of strings. All right? And if this doesn't have, I mean, I could do this, for example. That would be okay. All right. Both of those would return true in this case. I'm not going to write Java yes, yes, but you get the idea. All right. Methods that copy objects. That's the hardest part. Guess what? In my opinion, this little section that's about 5 or 6 pages in this chapter, this is the hardest part of the entire book. Even harder than the stuff you go over in the advanced class next semester. So when we start going through it, if you go, that doesn't really make a hell of a lot of sense, then don't worry about it. All right? We'll get into aggregation, which gets into that. I've already talked to you about the this reference variable, and so we'll go through that, but quickly. In interclass, that may or may not make sense to you, but what an interclass is it's a class within a class. I'm going to ask you a question, and I'll give you a hint. The answer is 1. All right? How many public classes can you have in a Java program? 1. But you can have as many classes in a Java program as you want, but only one can be public. You can embed classes within your public class. Those are called interclasses. That's totally legit. Those must be private. But you can do that. So why would you want to do that? It depends. You know, some people purposely obfuscate their code. And if you don't know what that means, they write it so only they understand it. you heard me say this. I had a friend when I worked for AT&T. That's what he did. He wrote macros. He showed me his code once. His name is Andy. He had a doctorate from the University of Illinois. A little older than I was when I started. He got his doctorate and he was still in his early 20s. The guy was brilliant. So he wrote this stuff, and he wrote macros for macros, etc. And he worked for AT&T, and then he quit. And he hired himself in across the street as a consultant, and he was hired by AT&T. He lived at home, so he didn't need the medical stuff, but they doubled his salary. And he already, now we're talking now in the early 80s. He was making 50 when he started, because I saw he was sitting next to me. I'm like, holy moly, I'm starting at 26 and he's making 50? Maybe that was why. All right. Enumerated types. I could make my own variable type and call it days of the week. And guess what its values would contain? Like Monday, Tuesday, Wednesday, etc. All right. So an enumerated type is you can create your own data type. All right. And that's what the chapter ends with. Garbage collection. I may have talked about garbage collection before, I may not have, but to just say it again really quickly, what Java does is it works in conjunction with the operating system, that every once in a while, when there are a few cycles free in the operating system, it calls the Java garbage collector. And it looks to see if there's any variables, anything that's being used in your program that's not being referenced in the program anymore, and it gets rid of it. This doesn't mean anything for what we've been doing so far. It doesn't really have anything to do with it, but it will when we go on and do other stuff. All right, that's enough for right now. And the last thing is they show you how you can use index cards for object collaboration. That we're really not going to spend much time on. All right. Each instance of a class has its own copy of the instance variables. You know this already. Again, if I make that person class and I say height, weight, eye color, hair color, we'll leave it those 4 pieces of information. Then I make a person called Tuan. All right? She's going to have different things than Eric's going to have. That makes sense? They'll both have an eye color, hair color, height, and weight, and whatever we put in there, but the values will be different. Looking at the two of them, I think the values will be different. All right? All right. But you could even have twins, and there's a chance that the values could be different, because that's why you want to put in other things like first name, etc. type of thing. All right? Those variables that you create as part of the class, those are called instance variables. So each instance of the class has its own copy. That's all they're saying. All right. Now that's as opposed to static. And this is a little bit hard to understand, but he really does a good job, I think. Again, this is me speaking. There's 2 different magical things that you can do with static. You can call the method directly without having an object. Did you hear what I just said? You can call a static method, not a variable now, like I told you before, but you can write static methods. If a method is static, you can call it directly without an instance of the class. If you go, first of all, I don't get that, and second of all, it sounds like it'd be wrong. Look on the screen right here. You can call, math is the name of a class, and one of the methods it has in it is sqrt, for square root. You can call that without having to create an instance of the math class, because square root is a static method. So you don't need an instance of the class, and he shows this in one of the programs. I'll allude to it in just a minute. If you want to say that something is static, you still have to say public, private, protected here, but then the word static, then the type, then the name, then the value. Okay, notice this. Here's the key thing. The field is initialized only once, regardless of the number of times you instantiate the class. So that's what I mentioned before. If I've got a variable that's called person counter, I'd set it equal, I'd say private static int person counter equals 0. It would only be 0 until I create my first person. After that, it would always be, if I keep adding to it, it'll just keep adding. All right? And they've got this demo in here, and I don't know how good that particular example is, but there's a metric demo that's on the bottom of page 361, and it goes on to page 362. And what he shows in there is he creates some stuff in there that's static, and he shows how you can call it directly without creating an instance of the class. All right. So what he says here is that would be like that would be our person count. You'd set it to 0, but when you created 3 different person objects, it would now be 3. Methods can be static, and variables can be static. To my knowledge, classes cannot be static. I don't know how that would really make a lot of sense. But you can have static methods, and a static method means you don't have to have an instance of the class. So you can call the method directly from the name of the class .method. You know how we did the months thing? We said months M1 equal new month type of thing. You wouldn't have to even do an M1 if you had a static method. You could just say month dot followed by it. All right? And that's what they're showing here. That's that metric example. So notice metric is the name of a class. So it's metric dot. They're not creating an instance of a class. There's no new in here. You don't have to new anything. And the first bullet is exactly what I just told you. And that's, again, that's the way that most of the Java library works. I mean, imagine if you wrote a program where you wanted to call 50 different methods that were built into Java, okay? And imagine if they weren't static. You'd have to create you'd have to instantiate that class every time. So that might be 50 different classes or objects you'd be instantiating. That would be a real pain. All right. Here's an example of an overloaded method. Again, what's the difference between these two? Well, the return type is different, but what has to be different is what's in the parentheses. All right, and I want to show you this. I don't know why people would do this, but I want to show you something that I've seen people do before. All right, so what I'm about to show you, please don't ever do that because it's dumb, but you could. All right. So here's what they just put in the book. I just literally copied it out. All right, so what we have here are, these are overloaded methods. Okay? And you notice that in this case, it says public, it's static, int, and here it's public static double. All right? But the reason they're overloaded is they've got the same name, but what's in here is different. At least the type has to be different. So what I've seen people do before, and Java will let you get away with what I'm going to show you. And just because you can get away with it, it's stupid to do, and don't ever do it. But you can. All right? So let's say that, let's pretend we only have one of these. Okay, to start with. So we're going to say here int n1, and we're going to say int, now we'll make it double, n2. All right, and then we'll say here return n1 times n2. In fact, that wouldn't even work. So we'll make this one a byte. That's what we'll do. Make that a byte. All right, that'll work the way that it is. Because if a byte's just a small integer, so I'm multiplying an int by an int, so that's fine. That would work fine. All right. So somebody else comes up with a grand idea and says, well, you know what? I want to do the exact same thing. Can I do this? See what they did? They just reversed the order, and you can do that. That's an overloaded method. Because one, the compiler never looks at the names of your variables. It just says int byte, and it says byte int. Does int byte equal byte int? No. Because order matters. You should never do that, but you can do that. I know people who program, and that's how they program. All right? Again, that's obfuscating your code. That's making it so you can understand it, but you're making it harder for other people. You should always shoot to not do that. So as it says, Java uses the method signature, the name, the type of parameters, and the order to determine which method to call. And notice that it says there, it's a process that's known as binding. These terms you should be familiar with. All right. As we go on in here, and you get into the advanced Java class, you'll hear about terms like early binded and late binded. If something is early binded, it has to be known at compile time. So the compiler has to know it. For instance, Java arrays, which we get into in the next chapter, are early binded. When you set up an array, you can't change its size. Well, how do you do it then? You can make an array list, but a regular array cannot change its size after you've declared it. You can't change. You can change what goes in it, but you can't change its size. All right. On the other hand, other things in other languages are late binded, which means that you don't figure them out until runtime. All right. And it's like the old two-edged sword. The good news about it being Late binded is, well, you don't need to know it till runtime, so it can work a lot better. That's good. Bad news is the system has to reconcile it at runtime, so it might run slower. That's bad. All right. And most languages, like Java, allow some things to be either early binded or late binded, or either. All right. Again, constructors can also always be loaded, overloaded as well, rather, and they show you the overloaded constructors starting on page 370. We've already looked at this. Again, you did overloaded constructors in the month program that we did the other day. It's one of the reasons I chose that one. All right. It says Java automatically provides a default constructor for a class. And that's kind of important just so you realize this. And if you remember when we first started in the semester, we did those payroll, I showed you that simple payroll program that we did. We didn't have any constructor. So if you don't write any constructor, Java writes one for you. So if I've got public class, let's use the month, okay? And I don't create a constructor, Java creates one for me, and it looks like this. And you go, well, that's dumb, it doesn't do anything. It's not true. As it says right here, it does some stuff. It automatically sets any numeric instance variables that you have to 0. It sets any char variables to an empty char. It sets reference instance variables to null, boolean to false, and it's supposed to also set strings equal to the empty string. So even if you don't do it, it's done for you by Java. Now, normally, once you start writing programs in the language, you wouldn't do it like that. You would never trust the system. You would do it. But when you're first learning and you don't even know they exist, it's good to know that it's being done for you. All right. So that's what we got into. We started with a no-arg constructor. Now, if you write a no-arg constructor, so if you write your own constructor, so literally if I write one that's like this, now we're telling Java not to use its own constructor, to use mine. And now it won't do anything because we told it to do nothing. So what I'm saying is if you leave that out of there, Java writes it for you. If you put that in, now it's yours. All right. And you can do whatever you want to do in it. And as the author mentions right here, if you do write your own, in the bottom bullet, if you do write your own, you should provide initialization for all instance fields. And he's got a pretty good program here on page, starting on 372, and it goes all the way through page 375. Then there's, yeah, I guess that's it. It's an inventory item program. And he shows you what's in it here, and he shows you the code, etc. And again, it's not a terribly long program, 80 lines, and then the demo is like 40 lines. Remember, you have all of the source code for the book. So if you're falling behind in here, or if there's something you don't understand, you should go back and take a look at that, at the source code that's in the book. Maybe even key in a program or two. All right. Again, remember we have people like John here too that are anxious and willing to help you. All right. All right. So passing objects as arguments to methods. Again, if you want to pass an object as a method, you pass an object reference. You always pass it. It says Java passes all arguments by value except for objects. All right. Technically, strings are objects too. All right. And as we'll get into in the next semester, well, I should say next chapter, arrays are also objects. Okay. So again, the copy isn't passed. A pointer to the object is passed. And it's really what it is it's the address and memory of where the object exists. So when you change what's there, you're making a permanent change. All right, and he shows an example of it right here. So if I pass in an entire rectangle, now here they're just doing a system.out.println, but if I came through there and I did a set length and a set width, I'm permanently changing it. And that's what he's getting to. So methods can return objects. So you can pass objects into methods. You can return objects from methods. All right. And again, he has another example here starting on page 390 that's just called return object. just to show you this in action, so to speak. All right. Then he gets into toString. Now, am I right in assuming here that you all understand, or hopefully it makes a little sense to you right now, why I went over toString when I did? Most Java developers that do this kind of programming that we're doing right now, I mean, if I'm writing a game, I'm not going to be overwriting toString because I'm probably not going to have strings in my game. All right, but for what we're doing, some semi, Java application programming, you might have reason to print out a lot of stuff. And what you get by doing this, and we talked about this before, if I do this, if I say stock XYZ company equals new stock, and I put in this, and then I say print that out with a string, the system doesn't know how to handle that. So it prints out a goofy memory address. Really, it's the address in memory of where that object, the beginning of that object is. That's all it is. So if we want to do that, we have to override our toString method. Then when we say system.out.println and we put in the name of the object, it'll give us what we want. All right. So all objects have a toString, but again, it returns the class name and a hash of the memory address of the object. It's usually, unless you're looking actually for where in memory something is, probably not going to help you. It's probably going to almost never, ever be what you want. All right. We talked a little bit already about the equals. Notice when you use double equals with reference variables, objects, all right, the memory addresses are compared. Do they both point to the same thing? Now, I showed you this before, but this bears repeating. Okay, you saw this. Okay, everybody saw that. But if I do this, all right, everybody see what I just did here? I just put in this line. Now I can use either one of these, and they'll be true. I can say if name1 equals name3, or I can say if name1 dot equals name3. Those will both be true because they're both pointing to the same area in memory. This, I've just taken name3 and I've made it an alias for name1. Okay. Now you might say, well, why would you do that? I'm not saying you should or shouldn't, but you can. So again, as mentioned, that's a mistake. Even though they hold the same thing, it'll come back and say the objects are not the same because only the address of the two are going to be compared to one another. There's a really good program, if this confuses you at all, that's called stock.java on 393 and 394. Again, it's about 50 lines long. Then the demo for it is about 20 lines long, and it's on 395, and it's what I just mentioned to you. All right, so this is what we use, that equals method that I already mentioned to you. Okay. Now, I mentioned this to you before, and as said, pages 398, 399, 400, and maybe going on a couple more pages than that, but these are some of the harder ones to understand. All right, we'll get into deep copies and shallow copies, etc. There's some good material out there on the web for this one. But it says there's two ways that you can copy an object. You cannot use the assignment operator, but you can do either a reference-only copy or you can do a deep copy. So what's the difference? The difference is that's a shallow copy right there. That's the reference-only, what I just showed you. All right. But if I literally go and I want to make a copy, and I go in there and I grab every single field that's in name 1 and copy it to name 2, that's a deep copy. Do you understand the difference? All right. So if I just make an alias so they both point to the same thing, now I'm talking about making a copy here. I'm not talking about checking for equality. If I do this, all right, but if I want to make sure, then I copy in every field, a field at a time. All right, and that's what the author is talking about with the deep copy. As it says right here, this involves creating a new instance of the class and copying the values from one object into the new object. So if you want to be sure, for lack of better words. Now, do you have to do that? Can't you do this? The answer is most of the time the reference only copy works. All right? But it depends on the type of code you're writing. If I'm writing code that's going to be used for an operating system or something like that, I'm going to be using deep copy. If I'm writing code that's going to be application code for a payroll program, I can probably get away with a reference only. All right? Yes? No, I'm talking about if I've got 10 fields, copying each field over from one object to the other object. Right? No, no. I mean, you could do that, but that's a little overkill. You could do that, though. And one of the things we get into in a later chapter is we start talking about some of the built-in string methods. That isn't even really hard to do. You can just put that into a loop and copy it over a character at a time if you want to do that. Yeah. All right. So they talk about copy constructors starting on the bottom of page 400. And the author says another way to create a copy of an object is to use a copy constructor. And he mentions there that simply it makes the object that is being created a copy of the object that was passed in as an argument. Oh, that makes a lot of sense. Notice what they're doing here, though. Stock company equal new stock XYZ, comma, 9.62. Then stock company 2 equals new stock, but instead of passing in values, they pass in the object that you had previously. Whether this is a good thing or a bad thing, one of the things the author is saying here is there's many times there are multiple ways of doing the same thing. So as always then, well, which one do you pick? You pick the one that makes the most sense to you. All right? If I've given 5 different ways of doing the same thing, I might try all 5. And I'm not going to lie to you, which one am I going to pick? Probably the one that I think is the easiest and the least error prone. That's the one I'm going to choose. All right. Aggregation. Creating an instance of one class as a reference in another class is called object aggregation. We may have talked about this before. I don't remember. But let's make it simple. I create a class that's called clock. Okay? The clock has in it, for instance variables, it has hour, minute, and second. Makes sense to everybody. All right? And I might have, set clock time, a bunch of other stuff. Then later, I want to create another class that's called alarm clock. I could make another whole class that had hour, minute, second, etc. But why should I do that if I already have a clock class? All right? I mean, a clock class probably, unless it was an alarm clock, but a regular clock class wouldn't have things like set alarm, turn alarm on, turn alarm off, etc., that kind of thing. But an alarm clock class would. So with that alarm clock class, one of the members of my alarm clock class could be a clock class. All right? And with that has what they're saying is, in that case, an alarm clock has a clock as one of its members. That's not inheritance. That's aggregation. And the example that they give here is pretty long, but if we look at it, let's take a look at it. All right, let's go back to the book and take a look at it. It starts on 402 and it goes up to about 408, something like that. We'll go through this and then we'll take a break. All right. So what you're saying is, instructors teach courses. Textbooks are used for courses. So in other words, when we look at the stuff that's in here, we've got an instructor, and you see all the instructor stuff. All right, so the instructor has a last name, a first name, and an office hour. They have 2 constructors. They have a set method, etc. So you can see all that kind of stuff. All right, and then you can see very similar types of thing for a textbook. But then notice for the course, notice this is what's new. What type is that variable? That variable is of a type of a class. See that? And once you do that, now you're able to access all of the methods of that class as part of this class. All right. So classes containing classes. Sometimes because it's an object-oriented language, sometimes you'll hear it as objects that contain other objects. But in essence, what it really is it's a class that contains another class. All right. In this case, course contains three elements. A course name, which is a string, instructor, which is another class, and textbook, which is another class. And if you understand that, that's where you should be right now. All right. So he writes the instructor class here on 402 and 403. And one of the things he does on 403 is he overrides the toString method. All right. Then he writes the textbook class on 404 and 405, and again overrides the toString method. Then on 406 and 407, he creates the course, and he does the overriding. Now, does that matter? What matters is turning up to page 408 and looking at the demo program. All right, so if you have your book and you want to take a look at that, what he has there is instructor, my instructor equals new instructor, Kramer for the last name, Sean for the first name, RH3010 for the office number, because those are the three components that a new instructor needs. All right. Then he creates a new textbook. It says textbook, my textbook equals new textbook. In the parentheses, he's got the title, starting out with Java, the author, Gaddis, and the publisher, Addison Wesley, because the textbook requires those three fields. All right. And then he creates a course object. All right. And that course, notice he passes in there the name of the course, Intro to Java, and then he passes in the two objects. This is getting fairly heavy, whether you realize it or not. It is. All right, but as you probably guess, all right, it gets harder as you go along. All right, when you start doing some of this stuff and you get into more heavy stuff, this is a continuation of what we talked about earlier. But on the bottom of 409, on 410, and on 411, he goes into a little bit more. We'll do this and we're going to take a break. But he talks about some of the problems you get with these deep copies and shallow copies. All right. So on the bottom of page 409, he says, let's focus on two specific practices that can help prevent security holes in your classes. All right. Number one says, perform deep copies when you create field objects. So again, when you're talking about objects that contain objects, as you get more and more into this and you write more and more complex programs, by doing stuff and using shallow copies, it gives you shortcuts. You write less code. All right? But you may or may not be doing exactly what it is you want to be doing. So what the author says, to be totally secure and do everything the way you want it to be done, do deep copies. Then return copies of field objects, not the original. Why would you want to return a copy instead of the original? Because what if you screwed it up? You still have the original then. Remember, that's not as simple as a variable like age, where if you goof it up, you give somebody a negative age. Well, that doesn't take much to change it. An object can be unbelievably complex with scores or even hundreds of different elements. And if you screw it up, that might take a while to go back and put it back together again. All right, and that's all the author is saying here on the bottom of 409. Okay, and then he says on 410 and 411, he says, perform deep copies when creating objects. He said, let's take a closer look at what we mean. And what he does is he explains what I just explained to you within the confines of this program that he just did with course, instructor, and textbook. All right. So you're going to read it and either say, well, whatever, and I'll do it if he makes me, if that's part of my grade or whatever, but otherwise, well, whatever. But all he's trying to do is show you best practices. Okay. In much the same way on 411 here, he says, return copies, and he shows you that, again, in the context of the instructor, textbook, and course that we just looked at. Then on the bottom of 411, he talks about full names. This is it. Okay. Anybody ever tried doing this? You say int age, system.out.println age equals plus age. If you try doing that and age hasn't been set, it depends on actually where you put that line of code that says int age. If you put this at the top of your program so it's not in any method, it'll usually come back and say age equals 0. Because remember that constructor will set it for you. But if you do this in a routine, what's going to come back is your program is going to error out, and it's going to come back and it's going to say this. And you may have seen that already, I don't know. But right now, if I declare this locally inside of a method, its value is null. And null pointer exception means I tried to get your variable. And again, remember, it uses pointers, but in the background. And it was pointing to null, and I can't handle that. I can't do anything with it. So I'm going to throw an exception. All right. And it's actually doing what it should be doing. Well, yeah, I don't know if this is what you're asking, but you could. Let's comment this out for a second. So let's say that where I've got ... here, there's some code. We don't even know what it is. We don't care. But you could say something like this. If age equal, you can check for null. So then you could say throw. You could either throw just a null pointer exception and have it say whatever you wanted it to do. No. So you can do that, if that's what you're asking. You can also create your own exception here. So if I wanted to create my own exception and call it no, I could create my own. I could do that too. All right, before we go on and go into this variable, which starts on page 414, it's 10:47. Let's take a break and we'll come back. I'll probably end up starting back up at like 5 after 11 because I want to produce this. It'll probably take that long.